Hi everyone. Today we'll discuss first principles of instruction developed by David Merrill, professor. So he has done this thing five principle of instruction. First is problem centered learning, second is activation, third is demonstration, fourth is application, and five is integration. The first one is problem centered learning. Problem centered learning, problem centered learning, it should be for real world problem. For example, a taxi is there, it charges flat 5 dirhams plus 1.2 for per each kilometer. Frame the problem. So what will be the problem? How to make it? So suppose y equal to 1.2 into x plus 5. This is the linear equation we are making. How much money? Suppose if 1 kilometer, this is x is the number of the kilometer. If he goes 1 kilometer, 1.25, 6.2 he has to pay. Like that 2 kilometer. It depends how many kilometer he is going, he is paying that. So this is the, it become like a formula for this problem, for this type of the problem. So it is application to the real world problem. What student they have learned. The problem should be problem centered learning means the problem should be application based. Next come in his is activation of prior knowledge. Activation of prior knowledge means what they have learned, what they know, what they know to what new knowledge. From what they know, they have to connect the new knowledge to it, so that unknown known to unknown, then unknown to known. You see, it became the cycle like this. This is known, unknown, unknown to known, known to unknown. This the cycle it become they are learning. So how what they know old concept, previous knowledge. In math, old concept means the tables, all the multiplication, everything, fundamental things. What they know. Suppose you are teaching the want to teach circles. So to teach circles, the student already they completed the what they have completed. They have completed the triangle. In triangle, they have completed the area and the perimeter. The same concept you are teaching them for the circles. So area is there, area they know perimeter, the concept of area. Their area is how much? Half base into height. Here area will be area equal to pi r square. And what is the perimeters? Here perimeter will become circumference 2 pi r. They know, that is prior knowledge. You are connected, you see. This is known. This is known to unknown. From again it's going on. You see, from here it is coming here, from here again. So this is the cycle of this. Then the third thing comes under demonstration. The third instructional strategy is demonstration. How you are going to demonstrate? By visual demonstration, like solving a problem, step by step solving a problem. One problem is there, you are showing the step how to solve the problem, or general method of solving a problem. Or you can model different methods for solving a problem. For example, for any problem there may be more than one method. You are using that, and different approaches. How you can do that? Then ask them, the student, make the student to understand the pattern and conclude the result. How to apply the formula, how to do this thing. Then comes next come the application part of it. Application means making the student the independent thinker. From guided practice to make them independent learner. Scaffolding, slowly remove the support. Make the exercises in such a way that their low level thinking will go to the high level thinking. Then immediate feedback should be there. Why? If you give the immediate feedback, whatever they have doing the reasoning will become perfect and good reasoners. It removes their misconception, and they will feel happy what they are learning and understanding. Then comes the last is integration. Integration means reflection, what they have read, what they have learned, and this thing they can integrate different area of their studies. Suppose what they have learned in math class they can apply in their other subject like chemistry, economics, biology, all other subjects, and they can create their own problem and make an application. So from biology, how the bacteria will multiply, all these things using equation, mathematical equation, they can go. So that's the application. Even in math also, from others branch of maths to the other branch of math, from geometry to integration, like that. What are the benefit for this? First principle of learning. Benefit is whatever they are learning, it become relevant for them. That means the student will not feel that they are not treating any learning there unnecessary thing. This is they will make a real world conversion. And one more benefit is scaffolding. That means you are supporting them, after some time you are removing the support. Thus we have discussed known, unknown to known, then again unknown to known, known to unknown, unknown to known. This is the cycle. And visualization, they what they are learning, the concept is becoming, they are having the clear concept, clarity of the concept, and they are active learner. If they are active learner, they are enjoying what they are learning, doing, and they are engaged in your class. And reflection, they make their own what they have learned, they make their own reflections, and they stick to it, and they get happy. And our aim is to make learning as a fun. They should learn the concept easily and happily, and can remember for a long time. Thanks for watching. You see all the five things of David Miller we have discussed. Task centered, problem centered, second activation, demonstration, application, then integration. And what are the benefit for this that we have discussed, and keeping in mind our math model, how we can apply in our math class. Thanks for watching. Please do subscribe my channel and share with your friends.